Swarnandhra College of Engineering and Technology. Unleash your potential. Build your career here. Godavari Delta in Andhra Pradesh, with its finest soils and pleasant waters, is the richest region for its age-old traditional and cultural heritage. The Vasishtha Godavari, a tribute of river Godavari, flows fluently with all that vibrant iridation spreading along its banks.
Our college was established in 2001 by the Vasishtha Education Society to produce global, competent and dynamic professionals, creating Center of Excellence in Technical Education for Empowerment. Apart from curriculum, we train in the latest technology like data science, VLSI, Python, full stack, Java full stack, SAP, process integration, ABAP, FICO and ERP.
Swarnandhra College of Engineering and Technology in Narasapur of West Godavari, vicinal to Vasishtha tributary, carries the baton of such a rich heritage with its dedicated efforts and support in imparting up-to-date, latest, ultra-modern, futuristic mode and phase of engineering education and tech knowledge.
We at Swarnandhra give importance to intersection between theory and practice, passion and present for good technical and practical knowledge. It makes our children ready for the industry.
With its more than 2 decades of untiring and uncompromising quest, empowering the next generation of engineers, Swarnandhra College of Engineering and Technology had unleashed the potential of thousands of enthusiastic students with its engineering program. Yes, Swarnandhra College of Engineering and Technology is pushing the boundaries of technology. Are you ready to join it? Do you want to forge your own path with its top-notch engineering curriculum? Don't you want to be part of a community of innovators, creators, and problem solvers?
Swarnandhra is a place where thinking out of the box is contagious, and it is also a place where ideas inspire change.
Here you are welcome to the prestigious Swarnandhra College of Engineering and Technology, where excellence meets innovation.
Swarnandhra College of Engineering and Technology is a well-maintained campus with green orchard in beautiful ambience, very conducive.
2,000 computers are available with LAN connection and an internet facility of 800 Mbps bandwidth and Wi-Fi signals spread to all the nook and corners of the campus. A separate computer center with digital library and a central library with 60,000 volumes and 9,500 titles are available for the students with hands-on experience in their respective fields. Workshops of all branches, namely mechanical, electronics, computer science, robotics, artificial intelligence, nanotechnology, are equipped with latest machinery and tools that help the students to hone their practical skills.
Swarnandhra constantly motivates its students towards fulfilling learning experience.
There are 5 separate hostels available in the campus of Swarnandhra College of Engineering and Technology. Hygienic mess and food courts. Round-the-clock security. CCTV surveillance in the campus. Departmental stores and ATM center serve the needs of students here.
Okay, sir.
support of industry professionals.
Your admission into Swarnandhra College of Engineering and Technology makes you transform your tomorrow with the skills you learn today.
Good evening, sir.
Because you're stepping into their engineering program molds your creative absorption into technological passion. The UG courses in BTech ranging from civil, mechanical, electrical and electronics and communication, computer science, information technology, artificial intelligence and machine learning,
College of Engineering
CSE
and
data science,
Technology.
CSE
Unleash your
cybersecurity,
potential.
CSE and
Build your
business
career
systems, artificial
here.
intelligence, data
Godavari
science,
Delta in Andhra
robotics,
Pradesh,
PG
with its
courses such
finest
as
soils
MBA,
and pleasant
MCA,
waters, is the
MTech,
richest
structural
region for
engineering,
its
power
traditional
electronics,
and cultural
CAD,
heritage. The
VLSI
Vashishta
systems
Godavari,
design,
a tribute
computer
of River
science and
Godavari,
engineering,
flows fluently
thermal
with all
engineering,
that vibrant
communication
erudition
systems,
spreading
diploma
along its
courses like
banks.
Our
electrical
college was
and
established
electronics,
in 2001 by the Vashishta
electronics
Education
and
Society
communication,
to
computer
produce
science
global,
and
competent
engineering,
and
artificial
dynamic
intelligence
professionals,
are
creating
all
center of
dealt
excellence in
with
technical
efficient
education for
range of
empowerment.
commitment and
Apart from
euphoria.
curriculum, we
Swarnandhra
train in the
College
latest
of
technology
Engineering and
like data
Technology
science,
not only
VLSI,
just offers
Python,
all these
full stack,
branches and
Java full
courses,
stack,
but also
SAP,
encourage its
process
students to
integration,
work on live
ABAP,
projects
FICO,
and collaborate
and
with their
ERP.
peers,
Swarnandhra
giving
College
them
of
a
Engineering and
taste of
Technology in
real-world
Narsapur
scenarios.
of West
Another college
Godavari,
have
visible to
outcome-based
the sister
education,
tributary,
choice-based
carries the
system,
baton of such a
open
rich
institutes for the
heritage
academic
with its
enhancement.
dedicated
They are all
efforts and
well-qualified
support
and
in
experienced
imparting
faculty
up-to-date,
involved in
latest,
quality education and
ultra-modern,
R&D
futuristic
activities.
mode and phase of
Faculty
engineering
members of
education.
Swarnandhra College of Engineering and Technology are not only knowledgeable but also passionate about teaching. They ensure that the students are equipped with the latest technical knowledge and are prepared to face the challenges of the industry. Swarnandhra College of Engineering and Technology paves the path to discover the power to innovate with its centers of excellence. The CM's Skill Excellence Center, IBM Center of Excellence, Indo-German Collaboration ARC Laboratory, Intel Center of Excellence, VMware Center of Excellence Laboratory, Dassault Systems Lab, Cisco Networking AWS Lab, Nanotechnology Research Laboratory, and IoT Incubation Center. Swarnandhra College of Engineering and Technology believes in the holistic development of its students, where in wide range of extracurricular activities that help students to develop their leadership skills, communication skills, and teamwork abilities. Fabulous
Sir, Virendra, sir.
auditorium that hosts various events and guest
Voice audible,
lectures
but video
throughout the
audio.
year, and sports facilities such as cricket, volleyball,
Okay.
Shall I stop, sir?
Let it.
basketball courts are top-notch,
You can stop, sir.
providing opportunity for the students to participate in variety of sports
Virendra, sir, you can stop.
and fitness activities. IEEE, ISTE, CSI student branch chapters are formed among students and they function quite effectively in Swarnandhra College of Engineering and Technology. The college has the permanent affiliation
Swarnandhra
to
College of
JNTU
Engineering
Kakinada,
and
is
Technology.
approved by
Unleash your
AICTE,
potential.
acquired an
Build
autonomous
your
status
career
from
here.
UGC, also
Godavari
accredited to
Delta
grade
in
A by
Andhra
NAC.
Pradesh, with its
Placement
finest
trainings
soils
are offered
and
to the
pleasant
students of
waters, is the
Swarnandhra
richest
College of
region for
Engineering and
its
Technology.
age-old
From first year
traditional and
onwards,
cultural
and
heritage.
100% placement
The
assistance
Vashishta
is a
Godavari,
promise
a tribute of River Godavari, flows fluently with all that vibrant erudition spreading along its banks.
Our college was established in 2001 by the
సార్ అదే సార్ ఫోన్ చేశారు మన సంజీవ్ గారు సంజీవ్ గారు ఫోన్ చేశారు ఆయన ఫోన్ చేశారు.
Sanjeev sir, my voice is audible or not?
Audible, sir.
Yes, sir. Audible, sir.
The participants are sitting in the classroom or they are also online?
Online, sir.
Oh, everybody is online. Okay.
Yes, sir. Yes, sir.
Sir, your voice more your voice slow గా
Swarnandhra College of Engineering and Technology. Unleash your potential. Build your career here. Godavari Delta in Andhra Pradesh, with its finest soils and pleasant waters, is the richest region for its age-old traditional and cultural heritage. The Vasishtha Godavari, a tribute of river Godavari, flows fluently with all that vibrant erudition spreading along its banks.
Our college was established in 2001 by the Vasishtha Education Society to produce global, competent and dynamic professionals, creating Center of Excellence in Technical Education for Empowerment. Apart from curriculum, we train in the latest technology like data science, VLSI, Python, full stack, Java, full stack,
3 minutes we will
SAP,
start.
process integration, ABAP, FICO and ERP.
Swarnandhra College of Engineering and Technology in Narasapur of West Godavari, vicinal to Vasishtha tributary, carries the baton of such rich heritage with its dedicated efforts and support in imparting up-to-date, latest, ultra-modern, futuristic mode and phase of engineering education and tech knowledge.
We at Swarnandhra give importance to intersection between theory and practice, passion and present for good technical and practical knowledge. It makes our children ready for the industry.
With its more than 2 decades of untiring and uncompromising quest, empowering the next generation of engineers, Swarnandhra College of Engineering and Technology had unleashed the potential of thousands of enthusiastic students with its engineering program. Yes, Swarnandhra College of Engineering and Technology is pushing the boundaries of technology. Are you ready to join it? Do you want to forge your own path with its top-notch engineering curriculum? Don't you want to be part of a community of innovators, creators, and problem solvers?
Swarnandhra is a place where thinking out of the box is contagious, and it is also a place where ideas inspire change.
Here you are welcome to the prestigious Swarnandhra College of Engineering and Technology, where excellence meets innovation.
Swarnandhra College of Engineering and Technology is a well-maintained campus with green orchard in beautiful ambience, very conducive.
2,000 computers are available with LAN connection and an internet facility of 800 Mbps bandwidth and Wi-Fi signals spread to all the nook and corners of the campus. A separate computer center with digital library and a central library with 60,000 volumes and 9,500 titles are available for the students with hands-on experience in their respective fields. Workshops of all branches, namely mechanical, electronics, computer science, robotics, artificial intelligence, nanotechnology, are equipped with latest machinery and tools that help the students to hone their practical skills.
Swarnandhra constantly motivates its students towards fulfilling learning experience.
There are 5 separate hostels available in the campus of Swarnandhra College of Engineering and Technology. Hygienic mess and food courts. Round-the-clock security. CCTV surveillance in the campus. Departmental stores and ATM center serve the needs of students here.
We are adapting latest technologies in the syllabus and curriculum periodically with the support of industry professionals.
Your admission into Swarnandhra College of Engineering and Technology makes
6-day online faculty development program on recent advancement in mechanical engineering and its applications. Ladies and gentlemen, MECH&ROBO, government institutions across the nation and abroad. We are also glad we have nearly 400 registered participants across the nation for this online education. Now it's time to invite our beloved captain of machine
smart materials, substantial energy systems, and simulation technology. As educators, seeing a breadth of these advancements is essential to deliver industry-aligned curricula and prepare students for future challenges. This FTP offers a valuable platform for academic enrichment, research collaboration, and knowledge sharing. I encourage all participants to engage actively, absorb new insights, and take full advantage of this excellent learning opportunity. I sincerely appreciate the efforts of this Department of Mechanical Engineering and the convener, Dr. Francis, head of the department, and the coordinators, Dr. Sanjeev Kumar and Dr. Lalit Narayana, and the vice principal, Dr. A. Gobichan sir, and the organizing committee for planning and execution this FDP with such professionals. I wish this program grants success and hope it brings forth new ideas, meaningful collaborations, and renewed energy for teaching and research. Thank you all and best wishes for the productive and inspiring week ahead. All the best. Jai Hind.
Thank you, sir, for your inspiration words. Now I would like to invite our beloved Vice Principal, Dr. A. Gobichand, who is the backbone of the department in making all the activities possible in a successful manner. Sir, please.
So, a very good evening to all. So, respected Principal Dr. S. Suresh Kumar Garu and all the eminent speakers from the various IITs and NITs. So, especially, I'm very much thankful to the today's speaker, so Dr. P. Karunakaran Garu from IIT Mumbai. So, thank you very much, sir, for accepting our invitation. So it gives me an immense pleasure to welcome you all the inauguration of our faculty development program. So organized at Swarnandhra College of Engineering and Technology by Department of Mechanical Engineering. So as the Vice Principal of Swarnandhra College of Engineering and Field Technology, I feel honored to be a part of an initiative that focuses on the enriching and improving the most valuable assets of any education institution about its faculty. So today, in today's era, so rapidly evolving the academic landscape and continuous learning and development are not just important, they are essential. Faculty development programs like this are vital for staying updated with the latest teaching methodologies, research trends, and technological advancements. So they provide a platform for introspection, innovation, and inspiration. So let us all make the most of this opportunity and together work forward and creating more dynamic, inclusive, and innovative educational environment. So all the best for all the participants. And once again, thank you for all the management and the coordinators and the head of the department of this particular FDP. And I hope this program will be a great success. Thank you for giving this wonderful opportunity. Thank you very much.
Thank you, sir, for your valuable speech. Next, I would like to invite Dr. M. Francis Luther King, Head of the Department, Mechanical Engineering, for your valuable speech, sir.
Honorable distinguished guest, respected principal, respected vice principal, sir, ladies and gentlemen, welcome you all to this 6-day faculty development program on recent advancements in mechanical engineering and its applications. Over the next few days, this online FDP is going to provide you all plenty of opportunities to learn about the recent developments, insights, and its application in the field of mechanical engineering and subdomains. The objective of this FDP is to provide a depth exposure and knowledge on the latest trend technologies and research advancements in the field of mechanical engineering, to bridge the gap between academic curriculum and industry practices, to develop faculty member skills in the emerging areas of mechanical engineering, promote interdisciplinary research and innovation by encouraging collaboration across various domains. I hope this FDP will be very fruitful in the coming days. And coming to the department was established in the year 2004, which offers UG and PG programs in mechanical engineering, including specializations in CAD/CAM and thermal. The department creating responsible and skilled mechanical engineers who can meet the needs of industry and society. The department was re-accredited by NBA in 2024 and recognized as a research center by J&K Kakinada. The department was supported by experienced faculty, including 7 doctorates. The Department of Mechanical Engineering is the hub of creativity, innovation, and academic excellence. The faculty members of the department and students are actively engaged in innovative research by providing students with a comprehensive education and preparing them for a successful career in industry and academia. The department has a strong connection with industry partners, providing students with opportunities for internship, research collaborations, and job placements across states. So on behalf of Mechanical Engineering Department, Swarnandhra College of Engineering Technology, Andhra Pradesh, we wish you all the pleasant and fruitful session of your time. I take this moment to thank our management, principal, vice principal, my fellow colleagues for having given the full collaboration and support for conducting this 6 days faculty development program. So thank you one and all. Happy learning.
Thank you, sir. Next, general instruction to the participants. Before we begin, let's be mindful of few things so that the session runs smoothly. Please keep yourself on mute to avoid disturbance. Ensure to maintain online decorum. Questions and answers will be invited via chat box. The feedback will be provided at the end of every session. 80% of attendance is mandatory and 75% of test mark is necessary for certificate. On behalf of the Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, Andhra Pradesh, we wish you all happy learning for the coming days. Now, to formally start our today evening, it's my pleasure to invite Professor Dr. R. Lalit Narayana to introduce our Day 1, Session 1 resource person. Sir.
Good evening, all of you. I am Dr. Lalit Narayana, Professor in Mechanical Department, Swarnandhra College of Engineering, Narsapur, West Godavari, Andhra Pradesh. I deeply honored to introduce our today's Session 1 speaker, Dr. K.P. Karunakaran Garu. So, Dr. Karunakaran is presently Hindustan Aeronautical Limited R&D chairperson in IIT Mumbai since 1994. His first career was in Hindustan Aeronautical Limited for almost a decade, 1984 to 1992. He has been teaching and researching in IIT Bombay since 1994. His research domain is manufacturing automation, which includes CNC technology and hybrid manufacturing. His passion is to develop a drone ambulance to operate among the terraces. His research is focused on product involving mission building. His publications are only byproducts. Dare with care is the working principle, and discrete, adaptive, and hybrids are the three words defining his approach. He is currently developing two electron beam hybrid manufacturing processes with a total outlay of 11 crores. One using powered fusion and other using multi-wire cladding. 25% of this project is contributed in cash by private industry partners, highlighted their relevance. His promise is to launch product at tenth of their important price through indigenization and innovation. Ladies and gentlemen, let us welcome Dr. K.P. Karunakar sir for the talk. Thank you.
Thank you, sir. Now I hand over the forum to our today resource person. Sir.
Yeah, I am now unmuted. My time is still 7:15.
Yes, sir. Yes, sir.
Okay. So, is my screen visible?
Yes, sir, visible, sir. You can take 5 to 10 minutes extra if you need, sir.
Okay, perfect. Yeah. Yeah. I hope it is in full screen mode.
Yes, sir, full screen.
Yeah, okay. If there is any problem in audio visual, kindly pass me so that we can correct it.
Sure, sir.
Thank you. So, very good evening to all of you. Thanks for inviting me for this program. I always enjoy interacting with the other college people, colleagues, as well as young students. I hope some students also will be present in this presentation. So, the topic I've chosen here is VTOL. VTOL stands for vertical takeoff and landing. Okay, in this screen, you will find a lot of VTOLs. The top two are known as amphibians. Okay, sorry, ornithopters. Okay, ornithopter means it flies like a bird. It will flap the wing, as you see here. It will flap the wing and then try to fly, very similar to the way the birds and insects fly. Okay, so for a long time, since the beginning, people were trying to build flying objects based on this concept, but it was not very successful because there were a lot of limitations on the materials to obtain such huge flapping wings, and most of the prime movers were all rotating type. So you have to put linkages to convert the rotations into flapping or oscillations. Therefore, that did not succeed much. Still, people have built this kind of flying objects, ornithopters, but they're not yet, they're more at the toy level. They have not gone to the level of deploying for any serious application. The next level of VTOL, vertical takeoff and landing systems, are, you are all familiar with the helicopters, the middle row, very first device. Okay, so the entire row, if you see, they have two rotors. in the first one you have a large rotor at the top and there is a small rotor at the tail. The second one has two rotors inline, that is known as tandem. Okay. In the third case, they are not tandem, but they are coaxial. Both rotors are mounted on the same axle and they rotate in the opposite direction. Okay. Now the fourth one also is very similar to the third one. This is also a coaxial type. I'll come to the difference little later. Okay. So we are talking about ornithopters as one type of VTOLs. Then we are talking about two rotor systems which we can commonly refer as helicopters. Of course, the bottom row, first two also can be referred as helicopters, but interestingly you will find that they do not have the second rotor. They have only one rotor. I will not spend too much time on this because our main focus will be onto the drones, but you also see that here there is only one rotor and you find that there is no engine in the body or fuselage of the helicopter. So the engine is not here or here. What you see at the tip of the helicopter, that is the engine. Okay, that's very, very interesting. As mechanical engineers, you should try to understand why we are able to, how we are able to eliminate one of the rotors in this by shifting the engine from the body to the tip. Okay, the second figure at the bottom row, you see that it is called rocket, which is powered by a monopropellant called hydrogen peroxide. The equation is very simple, H2O2. Water is H2O and this has one extra oxygen. So it is H2O2. The chemistry full name is hydrogen peroxide. It's not very expensive. For about 150 rupees, you get 1 liter of that, and it's a very good monopropellant. Okay, so through the fuselage or the body has the tank of H2O2. It is pumped through the shaft and then it comes to the side, and then the liquid H2O2 natural form is liquid. When it touches platinum, it becomes gas, high temperature gas, about probably 200 to 300 degrees centigrade you reach. So a jet comes out. So because of that jet, the rotor rotates. The concept is very similar to the lawn water sprinklers. You might have seen in the lawn people keep water sprinkler, and because of the pressure of the water itself, it comes out like a spray. So the working principle of this also is very similar to that. Okay, that means you put the engine or the rocket or some kind of thruster at the tip of the helicopter. Okay, so that way it becomes very light and you don't need one more rotor, because in all these places Newton is sitting there. Newton's third law of motion will be working there, whereas by putting the engine at the blade tip, they have smartly avoided that. Okay, so you try to understand it yourself. Just take it as an input that Newton's third law, that is the reaction force, will not be there in this. Okay, so these two are known as tip jet helicopter. Okay, you have a jet at the tip, so it's known as tip jet helicopter, and anything that produces a thrust at the tip can be used. For example, people put a huge compressor in the fuselage, pump the air through the axle and through the length of the blade, and then put a nozzle at the end, and it was able to rotate. People built one single seater. I have the video of it. That's a single seater helicopter available based on that. So anything that produces jet. So this is known as hydrogen peroxide rocket. This is known as ramjet. Ramjet, again, it's like a flute. There is no moving part inside. Nothing rotates inside. Okay, just the jet comes, it burns, and then goes away. Okay, so these are known as tip jet helicopters. So on the right bottom end, you see that these are, you're all familiar with it. This is the drone. Okay, so we will spend considerable time on drone, but I would like to start with explaining what we have done so far. Then I'll spend more time on the fundamentals related to these devices. Okay, we'll not talk too much about planes. We'll talk about only VTOL, vertical takeoff and landing systems. Then we'll also look at manned drones. Typically, drone is even now looked at as a toy. Okay, but we are talking about a drone that can carry a patient from the terrace of his building, drop him by flying straight on the terrace of the hospital in a matter of about 10 to 15 minutes, even in a city like Hyderabad or Mumbai, because it can fly at 60 kilometers per hour. We'll also discuss about power plants, because the conventional thinking is to immediately attach drone to electric power battery, but that is not true. The definition of drone doesn't mean that it should be electric. So we'll look at a few options of power plants, then a few slides on drone ambulance, and I'll conclude. This is how I planned my presentation. So we'll start with our development or evolution. We started working on drone way back in 2005. Okay, we are the first in the country to develop the drone. We received about 10 lakh money from AR&DB. Then we demonstrated in an event called MICAV, Micro Aerial Vehicle. In 2007, we demonstrated it, and we are the first. In 2008, Amir Khan's movie Three Idiots came. It gave a lot of popularity to drones in the country. At that time, the drone developed by our former student was used in the movie Not My Drone. And that boy finally started a company called Idea Forge. Idea Forge is still a very popular company in the country working in defense related activities. So we are the first to develop drones in the country way back in 2005. That's a video of our first drone. At that time, even the contra rotors were not available. It was totally unstable. The sensors were not very amenable. So you see that it's flying somewhere. Somehow we managed to.
Sir, please unmute, sir. Okay.
Oh, you didn't tell me at all. Should I repeat?
No, sir. No, continue, sir.
Okay. How did it happen? Okay. Okay, I told here that we are the first in the country to develop a drone. This is our first drone, or probably country's first drone. Okay, so last year we introduced it as part of our curriculum. We call the courses MS101, Makerspace. MS stands for Makerspace. So in the second half of the semester, about 6 weeks, each week has 2 lab sessions, so totally about 36 lab hours. 762 students built 127 drones. So that is a very good achievement, and that is still continuing for the third semester, because drone is a product which involves all fields of engineering. So we thought it is important to introduce drone because electronics is involved, chemistry is involved, fluid flow is involved, carbon fiber is involved. So almost any technology you name, control, that means electrical department, then computer science department, all are involved. So it's a very good package to teach what is mechanical engineering. So you can see how this boy who built this drone jumps. And we ensured that not a single blade cut happened. They were supposed to fly continuously for 30 seconds to earn the marks. Okay. Subsequently, I switched over to manned drone. In fact, initially I started with coaxial helicopter that I showed in the opening slide. Then we realized that larger propellers and powerful batteries are available. So we switched over to drone again way back in 2019. Okay, then we made a mock-up, demonstrated it in Delhi. It's a static mock-up. So we started the work in 2019, and in by 2021 I was able to fly the first drone, and this is the flight test on April 10 last year. And I don't allow my students to fly, so I only sit and fly because it is still not a very reliable product. So I could reach a height of about 10 meters and very stable. So you see that this has 8 rotors. And we used football as the landing gear. You see the bouncing is very good. And what we used for the body is stainless steel. You know, normally people talk about aluminum or carbon fiber material. We decided to use stainless steel and fabrication through welding, because that becomes very affordable. Not only affordable, it is also good in fatigue life. So then the power of 8 rotors was not enough. So either I should have gone for larger rotors. These rotors are 1 meter or 40 inch in dia. So we didn't have money to go for larger diameter. So we bought 4 more motors and then built a 12 rotor system. So you find that in order to save space, we keep rotors as pairs. Actually, so they are known as coaxial contra rotors. So there are 6 pairs of coaxial contra rotors in this. Recently in Andhra Pradesh also someone has tested it. There were news about that. This fluctuation is because of my expertise in flying. You see a football fell down also. So one of the footballs became loose and fell down. But it doesn't matter. There are still 5 more footballs to land. So the boy showing hand asking me to land because one football fell down. A younger fellow would have flown better, but it is too early for me to, allow anyone else to fly. So I only keep trying. Yeah. So these are the 2 manned drones we have developed, and this one with 12 rotors we could continuously fly for 15 minutes in our ground in hovering condition. So with slightly better batteries, they are available already. 40 ampere hour solid state batteries are available. If we get that, we'll get easily about 20 minutes of non-stop flying. Okay, based on this experience, our ambition is to develop a drone ambulance. So you see that at the center, there is a patient lying. On one side, we will have a nurse attending to him. We'll also have some instruments to measure the pulse or BP or whatever necessary, minimum device is required for about half an hour of flight. And then it will also be weatherproof. We will cover it nicely at the top, and the side also it can be covered. If necessary, good air bleed or air conditioning can be done. And we intend to operate from the terrace of the society buildings or the hospital terraces. So terrace to terrace has two important advantages. One is, these 8 rotors produce a lot of dust, and in this particular drone, the diameter of the rotor is 72 inches, which is close to 2 meters. So 8 rotors will produce a lot of dust. So the terrace of the building is a better option. So dust will not be there. And another problem is onlookers. Whenever a device like this lands, you will see a lot of people crowding there. So when you have the terrace operation, people will hardly be able to reach there. So terrace operation is something we are considering. And suppose there is an accident victim to be picked up from the nearby road, then what we are proposing is the drone will go there, hover at about 8 or 10 meter height, drop a mat of about 10 meter by 10 meters. You saw that in the video we had the mat. You see, this is actually a football ground, so we can't land on it directly. So we spread a mat of 15 meter by 15 meter. So even a mat of 10 meter by 10 meter should be enough. To make it light, we can make it out of the parachute cloth. So the pilot will drop it, people at the bottom can spread it. Then the pilot will be able to land it even in an unprepared or dusty environment. So this is an animation of what we are proposing. This is how the patient will be loaded. Then the door will close, then it will take off. So this is something we want to develop. We are, in fact, day after tomorrow, I'm making a presentation to DRDO for funding. So if we carry a mat, as I said, then we can even land in unprepared areas like the Siachen or Leh area where you need to pick up some emergency patient. So it is meant for such applications. So drone ambulance is a very noble application we are looking at. Its takeoff weight will be around 650 kg and it can have a payload of 250 kg easily. And if it is a battery version, you will get only about 20 minutes of time maximum. One may prove it for even 40 minutes, but when you actually plan a mission, you should not plan beyond 20 minutes using a battery-based system. Okay, now I'm going to focus a little bit on the fundamental. Probably we'll spend substantial time on this. Is the presentation going okay? If there is a problem, let me know. For example, I didn't notice that it was in mute. Okay. So you're all familiar with degrees of freedom. Any object in space has 6 degrees of freedom. So we can look at each of these with the degree of freedom. If you look at a train, although it can go from one place to the other involving 3 degrees of freedom, movement in X, Y, and also a turn, it is actually a 1 degree of freedom for the driver because the other 2 degrees of freedom are from the rail laying itself. He never turns it. Okay, but if you look at any other ground vehicle like a car or a bike, it has 3 degrees of freedom. It can move in X, Y, and also turn around its vertical axis. It should not turn around any other axis, then you call it as an accident. Okay, now coming to the plane has all 6 degrees of freedom, but it is unidirectional. Okay, it cannot be, for example, it cannot come back. It can only go forward and it cannot stand in a place. That is called hovering. Flying in one spot, it is called hovering. So a plane cannot hover. Whereas a helicopter truly has all 6 degrees of freedom. It can go back and forth in all the 3 linear axes and all the 3 rotary axes. Okay, now when we look at the mechanism by which we produce lift, irrespective of whether it's a plane or helicopter, you have surfaces. In this case, you have surface which is rotating. Okay, the blade is the surface here. Here, wing is the surface. Okay, wing is not rotating, so it's called fixed wing. Here, the blade is rotating, so it is called rotary wing. Okay, ornithopter is called flapping wing. Okay, so whichever way it is, if you look at the cross section of the wing or the blade, it will have this kind of aerofoil shape. It could be a symmetric aerofoil shape, or it could be asymmetric as it is shown in this case. It could have different angles. So that angle is known as, compared to the median axis, with respect to the flow direction or flying direction, the angle is called angle of attack. Okay, remember this word, angle of attack. The angle at which the air is attacking the aerofoil, that's called angle of attack. So by 2 things you are controlling lift. One is by the forward velocity of the plane. You have a propeller or an engine or jet which is pulling the plane. Okay, so you have a forward velocity created by the engine. So the air is flowing over the wing. In this case, you have the rotation. The rotation creates the relative velocity between the air and the blade. So by doing either pulling the plane forward or rotating the blade, you create a relative velocity. In addition to that, by default, the wing has an angle of attack. You can control the angle of attack by controlling the control surfaces. In this case, here it is known as aileron, here it is known as elevator, and the vertical will be known as the rudder. Okay, so that means there are 2 things which are responsible for the lift of the aerofoil. One is the velocity, relative velocity of the air and the aerofoil. Okay, when obviously when the relative velocity is more, you are going to get more lift. The other parameter is angle of attack. You can see that the first figure has less angle of attack. Here it is shown as 6 degrees. Second one has 15 degrees. Third has 25 degrees. So both the angle of attack and the rotational velocity of the helicopter or forward velocity of the plane have to be controlled in order to get the required lift. But you will find that both have a limit. For example, let's consider angle of attack 6 degrees. You see that the flow or the air hitting the tip of the profile divides into 2 parts. Nicely it hugs on the surface and then it joins at the tip. This is a typical laminar flow. Okay, now in this you see that the distance traveled by this particle, any particle of this flow, the distance traveled is more compared to the distance traveled by the bottom flow. So that creates a relative difference in pressure. You know Bernoulli's law. By looking at it, you can say that there will be a partial vacuum, or the pressure drop is created at the top and the pressure is high at the bottom, so it tends to lift. That is called lift. Now whenever there is a lift, it will be always associated with some amount of drag. Like if you want to walk, you move forward, but then when you walk you also have friction. So it's very similar to that. Drag is a form of friction for fluids. When we say regular friction, it is between 2 solids, leg and the ground, or the tire of the wheel and the ground or road. Whereas here we are talking about the resistance offered for the flow. So as the angle of attack increases, you can see that, you can visualize that the drag increases, but something very interesting happens at the trailing edge of the aerofoil. You see that here the flow is nicely hugging, touching the tip and then comes out. Whereas here, it comes out of the top surface much earlier. It doesn't go flow till this point, it separates. This is known as flow separation. Okay, flow separation leads to loss of lift because the distance becomes less. You see the distance traveled here, you see the distance traveled here. The distance traveled is less, so you lose your lift. And here it becomes even worse. Therefore, you don't get any lift and it will simply fall like a stone. Okay, so that is why I said you need both of them. You need rotation or forward velocity. You call it forward velocity because if you have rotation, forward velocity is nothing but pi dn by 60. Okay, so we'll talk about relative velocity and we'll talk about angle of attack. When so angle of attack, you cannot go far beyond. Maybe you can go up to 6 degrees, 0 to 6 degrees. Okay, the moment you go beyond that, flow separation starts, so it loses its effectiveness. Okay, so forward velocity is better instead of higher angle of attack. So these are the two parameters that control the lift, which is associated with some amount of drag also. Okay, now we'll come to the control functions. If you take a plane, what are the controls you want to do? You want the plane to go up and down, okay? And you also want the plane to move forward, you want it to take turn and all that. So in terms of Cartesian coordinate system, and if we assume that the length, along the length we have x-axis, along the wing we have y-axis, and the vertical thing is z-axis, then we can say that we want to move along the positive x direction, along the positive or negative y direction, along the positive or negative z direction. Okay, so three directions, linear directions of x, y, and z. In addition, we also would like to rotate about the z-axis. That's all we want. Okay, but in reality, it is not going to be so straightforward. In reality, there are only 4 controls. Okay, they will have different names. One control is power or throttle. Okay, you increase the power delivered by the engine. Maybe here there is a propeller, the propeller rotates fast. So what does it lead to? It leads to forward velocity, increase in the forward velocity. So throttle is 1. Okay, then you have 3 things: pitch, roll, and yaw. Okay, so I told you this is the length, the flying direction is x-axis. Okay, about that flying direction, if the nose is going up or down, we call it as pitch. Okay, so try to remember this. If the plane's nose is going up or down, you call it as pitch up or pitch down. Okay, then along the direction of flight, if the plane rotates, okay, then you call it as roll. Okay, it can roll towards the left or it can roll towards the right. Okay, so that is roll. So roll corresponds to rotation about x-axis. Pitch corresponds to rotation about y-axis. Yaw corresponds to rotation about the z-axis or vertical axis. Nothing called vertical axis because the plane is in space. So you have to talk in terms of the axis of the plane. So it is z-axis, which is controlled by rudder. So when you talk about plane, you have 3 sets of control surfaces in addition to throttle. Throttle takes care of the forward velocity. Okay, then you have at the wing extreme, you have what are known as ailerons. You see the spelling here, ailerons. Okay, that is responsible for roll, and that is because the ailerons move in opposite direction. If left side goes up, right side will go down. Okay, and vice versa. So they are connected oppositely. So that is responsible for the roll. Okay, now at the tail fin, you have a you have an elevator. It's called elevator because it causes to elevate or go up or down. That's known as pitch control, nose up or nose down. Okay, the moment nose is up, the plane will climb. When the nose is down, it will land. Now on the vertical fin, this is a vertical fin, you have a rudder. You are all familiar with rudder because all boats have rudders. So rudder is responsible for vertical rotation about z-axis. It is known as yaw. So please try to get used to these names. Power side is responsible for throttle and yaw. Okay, throttle and yaw will be in one hand, and the roll and pitch will be on the other hand, because roll and pitch corresponds to movement along x and y direction. So roll and pitch will be in one hand, throttle and power will be in the other hand. And you will also find that the throttle does not have a spring back. It's a joystick. So the throttle joystick, if you push it, it will stay where it is. It will not come back on its own. You have to bring it back. Whereas the other three will spring back to the neutral condition, because if you push on the pitch, it will move forward. Okay, but then if you release it, the moving forward will stop. Okay, but in throttle, you want it to be locked at a particular vertical position, because throttle is responsible for the vertical position. So you keep the throttle at the required level so that your speed of flight and altitude are set, and then you control the other three continuously. Okay, but sometimes when power is consumed for pitch, roll or yaw, to compensate for it, you may have to adjust little bit of throttle, but not too much. It's very small. Therefore, normal systems have the throttle without spring return, whereas the other three controls will have spring return. Okay, so this is about the control. Let's quickly see. We discussed elaborately about how lift. You only control the rotations in order to achieve the translatory movements you need. Okay, if you study a little bit of dynamics, you might study that the radius of turn for a plane will be better. See, rudder alone can create the movement or rotation about z-axis, but if you combine it with aileron, then you will have a tight turn, or the radius of turn can be very less. This you can compare with cycle. When you do cycling, you will find that the fellows, if he is taking a left turn, he will bang the complete cycle towards the left. Motorbike people also will do that. Okay, so roll combined with pitch control, rudder control, leads to tighter of turn. Okay, I'll share the PPT of this so that you will be able to appreciate later. Now I'm going to talk about stability versus maneuverability. Maneuverability means how quickly you are able to make the move in the required way. And stability means you don't control anything, you let the plane fall, it lands smoothly. Okay, so how stable it is, how maneuverable it is. So they are actually opposite to each other. If a plane is very stable, and that will not be very maneuverable. For example, A380, the largest plane ever built, that doesn't have too much of maneuverability, but it will have very high stability. On the other hand, if you look at F-16, which is a fighter aircraft, it should be highly maneuverable. Okay, you do dogfight with the fighter aircraft. You chase one by the other. So you have to be highly maneuverable. So in that case, it will not be stable. They will achieve stability electronically. Mechanically, it will be unstable. Electronically, it will be very stable. Now, the stability and maneuverability are indicated by 2 points. One point is the center of gravity, you all know. Other point is center of lift. So let's say this is the wing of the plane. Center of lift will be somewhere on the wing of the plane, because wing only is creating the lift. So something like 1/3 of the card, you will have the center of lift. your wing should be positioned such a way that the center of gravity is in front of the plane. This is very important. If this is the case, then you will have very good stability. Okay. If the center of gravity is below center of lift, the plane will not be stable, but it will be highly maneuverable. Okay, or highly controllable. Quick control is possible. So typically in fighter aircraft, CG will be behind the CL, and this is what is shown here is meant for the passenger aircraft. Now we are actually not having enough time. I've already consumed I think 40 minutes. I have half an hour more. Let me try to explain this. See, imagine that your lost power, okay? Your throttle is brought to zero. Then what will happen? It will not produce enough lift, okay? That means the plane will fall down because its weight is more than the lift, so the plane will fall down. Now, when the plane is falling down, you will find that a moment is created. Whatever lift is created, it is less than the weight, but the weight is acting along the center of gravity and lift is acting behind it. So there's a moment created. This moment will not make the plane just fall down, it will also cause it to nose down. Okay, so it is causing the nose down. That is, a rotation in this direction is taking place. When that happens, then what is the net result of it? There is a relative increase in angle of attack. So your velocity is less, but the angle of attack is increasing. The moment angle of attack increases, then lift starts gaining. Okay, then you are able to recover out of it. So whenever the plane falls down, if nose diving is taking place, it has much better chance of recovery. Okay, so this is the principle behind that. So maneuverability and stability are opposite of each other. Fighters will have less stability and they achieve the stability through electronic control. That is known as fly-by-wire in the parlance of the designers. Okay, some more things I have to talk in this slide. In terms of CG tolerance, in the case of plane, the CG tolerance is along the X direction. Whereas if you look at a helicopter, the entire helicopter is hanging on a single line, which is the axle of the rotor. So you don't have too much of CG tolerance. But if you look at the tandem rotor helicopter, which is the, Boeing has something called Chinook. Most of the armies have this. Okay, so here you can walk from one end to the other. So along the flying direction, you have the flexibility or center of gravity tolerance, because CG can be anywhere in this line. But when you look at a drone, you have huge tolerance on center of gravity because you have 4 points lifting. Okay, so if you connect the all points by either a square or hexagon, within that square or hexagon, it can have the center of gravity lying. Then it is stable. So that explains why a multi-rotor is far more stable than the other helicopters. Okay, now we'll see a little more about helicopters. This is how a typical helicopter we all see looks like. You have a main rotor and the body is known as fuselage, and this is the cockpit, and this is a skid type of landing gear. You have a tail boom, and the tail boom has a rotor, which is the tail rotor. Okay, now you will find that in all devices, whether it is electric motor or I'll show the picture. I'll come back to that later. Where is it? That is important to show, so I'll show that. This graph. So whether it is an electric motor or an IC engine or a steam engine, anything that produces the power or the motive power, you'll find that with respect to the RPM, it follows a parabola. Okay, there is a point at which the efficiency will be maximum. So speed versus efficiency curve is this black curve. Okay, the x-axis is speed, y-axis is the efficiency. So this is the efficiency curve, which is a parabola. So you should always try to operate in this region. Okay, now the red color curve, it is the power. Okay, so you find that at the lowest RPM, the power is maximum. Okay, at the highest RPM, the power is minimum. Okay, so what should the point at which operate? In order to have good fuel efficiency, you will always operate at this point. So you will operate at maximum efficiency point, which means that your power will not be maximum. That is why, whenever we design the drone, we look at the curve and we normally design it for 50% of the maximum power possible. Okay, so power will not be the maximum power possible because it should correspond to this. So in order to respect this, that means, let's say you are at, let's say this in a percentage, or he is giving in some kind of unit hertz, let's say it's some kind of RPM. Let's take a regular IC engine where the around 6,000 RPM, your efficiency is high. Then you should remain within plus minus 500 of that 6,000 RPM. So you should operate within this range in order to be efficient. This is true with all power systems. Now I am coming back to this. So here I would like to, typically helicopter, in this case, let me assume a value 1000 RPM. So I would like to operate it between 900 to maybe 1100, not beyond, in order to have good fuel efficiency. But then that means my pi/dn by 60 gets fixed almost. The forward velocity with respect to the blade gets almost fixed. So what is the other alternative you have? You have the angle of attack. Okay, so you can control the angle of attack. So in helicopters, both the tail rotor and the main rotor rotate almost at the same RPM with maybe 20% plus minus variation. Okay, so by adjusting the angle of attack only, they make it go up or down. Okay, so that is mainly for getting higher efficiency. This is a very important point you have to appreciate. Okay, so they are doing pitch control. That means it's not like our regular fan where the blades are at fixed position and keeps rotating. Here, this fan is rotating. At the same time, the angle of the fan keeps changing around each rotation. That is one thing you have to remember. The other thing you have to remember is, this is nothing but a fan. Okay, in our house, I have a fan running in my room. The fan is connected to the ceiling. Okay, the ceiling prevents, when the fan rotates in one direction, the Newton's reaction causes the building to rotate in the other direction, but the building is so heavy that it doesn't happen. But in this case of a helicopter, you will see that there is nothing like a ceiling. Entire thing is in air. Therefore, the body tends to rotate in the opposite direction of the main rotor. If you want, next time, note it down in your notebook. When you happen to see a helicopter video, watch it carefully during takeoff. Okay? As long as it is in the ground, it will be okay. But the moment it lifts off, you will find that it tries to swing to one side. That is because of the third law of Newton. Reaction takes place. Then immediately the pilot gets control of it. Okay? How does he control? He controls using the tail rotor. Okay? So by throwing air in the opposite direction of rotation, he is able to bring it to the stable condition. That is the reason why you have tail rotor. So main rotor tries to rotate the body in the opposite direction. To counter that, you have tail rotor. Now it has two purposes. One purpose is to counter the reactive forces. Second purpose is to cause a turn. You want to turn to some other direction and then fly in that direction. So the turn, which is also known as yaw is also controlled by tail rotor. So tail rotor is responsible for two things. One is cancellation of the torque reaction by the main rotor. Second is by creating a differential of that torque reaction to cause a yaw motion. That is a rotation about vertical direction. I think it is easy to understand. Okay, now coming to power, you understand very well. Just throttle or increase the fuel or decrease the fuel, you have power. And here again, your power is in a closed loop so as to maintain the RPM within that plus minus 20% of the efficient speed. Okay, so power also doesn't play a great role. It only maintains the required energy for flying. Okay, now I am going to introduce two important terms which are related to pitch control. So all helicopters fly by pitch control. One is called collective pitch, another is called cyclic pitch. Let me see whether this video runs. Oh, no. This video doesn't seem to run. Let me escape. We are here. Okay, this is not a video, I'm sorry. Earlier I thought I kept it as a video. It's not. Okay, it doesn't matter. I hope my videos. Have I stopped the sharing?
Okay.
Is it okay? Presentation mode is on?
Yes, sir, visible.
Okay, okay. Okay, so try to appreciate that as you rotate, when you tilt the blade by the same angle, okay, irrespective of the angle of 0 to 360 degrees, if the blades are tilted by 6 degrees, the helicopter will rise at some rate vertically. If you make it 8 degrees, it will rise higher than that. If you make it 10 degrees, it will rise even higher. That means when you change the tilt of the rotor blade, then it starts going up and down. Okay, and all three blades are tilted by the same value. So we call that as collective pitch. When all three blades are tilted by the same angle, it causes going up and down. This is known as collective pitch. So we have seen how yaw is controlled. Yaw is controlled by the tail rotor pushing it a little harder or less harder. And power is achieved, or going up and down is achieved by collective pitch. Now there's something called cyclic pitch. In the case of cyclic pitch, if you want to move forward, okay, if you are moving forward, then when the blade is making a rotation and that blade comes to the front, then you keep higher angle of attack there. Then what will happen? It will produce, you keep higher angle of attack when it is the rearmost. When it comes to the frontmost, you keep lower angle of attack. Let us say 12 degree of angle of attack here and 6 degrees of angle of attack here. When that happens, what is the tendency? There is a tendency for the blade to create more lift when it is at the back side and less lift when it is in the front side. This will be done by all blades. Okay, so whenever the blade is at the rear, it produces less lift. Whenever it's at the front, it produces more lift. What is the net result? About the axle, the blade will try to tilt the helicopter in the forward direction or nose down direction. Okay, so this will cause the helicopter to move forward. So similarly, if you want to move on the left direction, then you will increase the angle of attack more on the right side, less on the left side. That means throughout 0 to 360 degrees of rotation of any blade, the angle of attack is continuously changed. Okay, so this is how they achieve the X and Y motion or pitch and roll motion. So remember, Yaw control is with that the tail rotor. Power is by collective pitch. Pitch and roll controls are by cyclic pitch. Okay. So this actually was available as a video. For some reason, it is not running. So ignore it. So collective pitch purpose is up and down. Cyclic pitch purpose is forward, backward, sideward, or stalling corrections. Okay. We'll go to the next slide. Now I'm going to tell a little bit about stalling. Okay. So what is stalling? I already told you stalling is the result of flow separation or lower velocity. These are the two reasons. One is the velocity or the forward velocity is so low that you don't get enough lift. Another is the angle of attack is too high, flow separation takes place. Okay, when either of them or both of them happen, the plane will just fall down. So when it falls down, if the CG is behind the center of lift, this is the situation that will happen. Then the tail will come downward and hit the ground. If it is the other way, the nose down will take place and then it will automatically recover itself. That's why we call that as a stable arrangement. In fact, when I was very young, I was about 22 years old. Right now I am 63 years. At that time, I took permission of the NCC and then had a glider flight, and I read about stalling and all. So I tried to show up my knowledge to the pilot. I asked the pilot what is stalling. Okay. Then he said, I'll show you what is stalling. He simply pulled the pitch stick and then the angle of attack increased. It went almost vertically up. Then we were literally falling down. When we were falling down, it went to a nose down condition because CG was in the front. Then it recovered automatically. That's what stalling, he said. He said we just now underwent stalling. Okay, if the plane is designed properly with center of gravity in the front, then you will recover nicely from stalling. Now come to helicopter. What is the meaning of stalling in helicopter? So as I said, throughout 0 to 360 rotation, each blade's angle keeps on changing in some form. Okay. Now let us look at just hovering, flying at one spot. Okay. When you fly at one spot, the relative velocity is nothing but pi dn by 60. Okay. So the plane will start lifting comfortably and it will be standing at some point. Let us say that at the RPM of 1000, let's say that it remains horizontal at a particular altitude. Now, the moment you start moving forward, okay, then what happens? Pi dn by 60 is no longer valid because with respect to the still air here, in this, it is decreasing. The relative velocity is decreasing because it is retarding from the air. Whereas here, it is going closer to that. So in one side, relative velocity increases, the other side, relative velocity decreases. Net result is what? There will be a rolling happening because left half of the disc produces less lift, right half produces more lift. It will cause the helicopter to roll about itself. So the pilot will use his roll control of the joystick to correct it. But there is a limit up to which he can really correct it because he will go beyond the limit of it. Okay. Then he won't be able to do any correction. Then the helicopter will go for a spin or a roll and then it will enter into an accident. So this is called stalling in the case of helicopter. So the translation of this is that the maximum speed of a helicopter is the stalling speed. The minimum speed of the helicopter is 0 because it can hover, it can stand in one place. So for a helicopter, it's very similar to the tricycle. You know, you can stand there. Okay. So it will be very stable at 0 velocity, but it cannot go beyond some velocity because it will lose roll control. But in the case of plane, you always need a forward velocity. Okay, so the plane's minimum velocity will be stalling speed, and its maximum velocity can be anything decided by its structural strength and engine power. That way, you'll find that you will never have a helicopter which can do a supersonic flight, but you will never also have a plane which can stand in air at one place. Okay, but it can go at Mach 4, Mach 5, anything is possible. Okay, fighter aircrafts easily fly up to Mach 2. MiG-21, which I'm familiar with, it used to fly at Mach 2.1 or something in those days, way back in 1970s. Okay, today, they're talking about hypersonic speeds, which is Mach 5 and above. Okay, so we were talking about a lot of things. Have control on yourself. Note down some words which you can read about later, because in one lecture you cannot completely understand everything. So we talked about two types of pitches: collective pitch and cyclic pitch. Okay. Now this is the traditional helicopter where we do collective pitch and cyclic pitch, and it's very efficient. But if you are a hobbyist, you want to build a single seater, then people normally use a fixed pitch, and then they completely tilt the body of the engine, and then by body tilting they achieve that. We'll not go into the depth of it. We'll move forward because I have not yet come to the drone except mentioning in the beginning. Now let's have a quick comparison of flapping, fixed and rotary wing systems. By rotary wing we are referring to helicopters and drones. By fixed wing we refer to the planes. By flapping wing we refer to ornithopters. Ornithopters, as I said, they're not yet in evolved condition because of the material and other limitations. Flow analysis, again, a very, very complex thing to be done in ornithopters. So this table only compare the fixed wing and rotary wing, or planes and helicopters and drones. Okay, so plane has 0 rotors. I'm not talking about the propeller. Propeller is, we don't consider as a rotor. By rotor or control surface we refer to the thing that is helping in maneuvering. Okay, one is just the prime moving, the other is maneuvering. Okay, so we are not talking about, so I will say that fixed wing has 0 rotors, rotary wing has 2 or more rotors, or 1 or more rotors. The tip jet has just 1 rotor. All sorts of helicopters have 2 rotors. Drones have 3 and more motors. The stalling speed is the lowest in the plane, and it can reach even hypersonic flight. Stalling speed is the upper limit in the case of helicopters. So helicopters hardly fly at 100 km per hour. Maybe the fighter helicopters fly about 200 250 km per hour, because max speed is around 900 km per hour. Okay, plane is very stable. Even if the engine is switched off, it can land comfortably. There is a case where the plane landed in Hudson River in USA due to a bird hit. Comfortably it landed and all people were saved. But in the case of any such thing, when an engine failure takes place, the helicopter simply falls like a stone, because not only the main rotor stops, tail rotor also stops, and sometimes they try to do freewheel the main rotor. In that case, it can go for a spin. Tail rotor failure is very, very common. 86% of helicopter accidents are attributed to the tail rotor failure. So we'll move forward. I'll skip this slide. I've grouped all VTOLs here. So this is the plane, this is not a VTOL, and flapping wing. So I'm putting the number of rotors. Number of rotors is 0 here, and planes use the control surface, aileron, elevator, and rudder. Flapping wing, the wings are flapped, or there's a tail wing which is twisted. So flapping and twisted, it has 0 rotor. This is a conventional helicopter, tandem rotor helicopter, coaxial rotor helicopter. In all these, there are 2 rotors. Okay, here they are equal in size, here they are unequal in size. Pitch control is the most common thing used. In this small helicopters, body tilt is used, number of rotors remain the same. So all these will be called helicopters of different kinds. And this I have already told you in the opening slide. This is called tip jet. It has only one rotor. And here we are talking about multi-copter or a drone. Theoretically 3 rotors are enough, but very commonly people use pairs of rotors. Let me watch the time, about 6 minutes left. So here again, I'm putting all of them together just to highlight some of these points. Now, you can add more and more rotors. We have proved that 3 rotors are good enough for a stable flight, but typically people use even number of rotors. So when you talk about even number of rotors, then 4 becomes the minimum, because you always use a fixed blade. There is absolutely no pitch control. The pitch will be fixed in all drones. That is a very distinct feature of a drone. There will not be any pitch control. Only the speed control will be used in a drone. And by adding more and more rotors, you are increasing the power of the helicopter load carrying capacity. That is one. The other thing is the reliability, because some motor may fail. In that case, it should not fall down. So if you have only 3 rotors, then when one motor fails, 2 rotors will not be able to stabilize. And among 4 rotors, if one fails, the 3 may be able to stabilize. So the more and more rotors you have redundancy. So you achieve reliability of the device through redundancy. Okay, so you also see one more thing. In this, you have all the rotors are in one plane. In the top 2, all the rotors are in one plane. This is hexcopter, this is octocopter. 8 rotors, 6 rotors. Now here you have same hexcopter, but they are in pairs, defining a triangle. Here the 8 rotors are on 4 corners of a square or a rectangle. Okay, so this way 2 benefits are happening. One is you are saving space. Okay, when one rotor is on top of the other, you are saving space. That is one. The other thing is the bottom rotor is expected to be more efficient than the top rotor. Okay, just note down this point, how it is more efficient, you understand through fluid dynamics. Okay, so these I have already told you. And these are all the various components going into a drone. Propellers, you use fixed pitch propellers. Recently, we have located a 80-inch propeller, which is 40 inches to 1016. So 2.032 meter is the diameter. It's a very large propeller. So each propeller can produce a lift of about 200 kg. So if you have 4 rotors, 800 kg lift is possible. So propellers today are available up to 80-inch commercially. You can also order special propellers if you need bigger ones, but 80 itself is too big. Okay, then these propellers are in electric drones driven by motors, and motors always need what is known as ESC, electronic speed control. The motors used typically are called BLDC motors, brushless DC motors. So this forms a combo. Typically when you try to buy motors for your toy drone, they will say combo. Propeller, motor and ESC will be optimized nicely and you can buy from companies. So we call it as combo, propeller, motor and ESC. Now batteries again very important. We started with lithium polymer. We used to say LiPo, lithium polymer batteries. And of late, we are talking about solid state lithium ion batteries. Batteries are associated with something called a C rating. Okay, apart from voltage, there will be 2 specifications for a battery. One specification is the voltage it can deliver. Okay, for example, if you talk about lithium ion battery, the maximum charge voltage will be 4.2 and it can be discharged till it becomes 2.5, then you have to put it for charging. Okay, and these batteries are available as 2500 milliampere hour and things like that. Okay, today for our manned drone we use batteries which are 40 ampere hour. Okay, so think of 400 volt batteries having 40 ampere hour. So you can visualize what's the kind of energy it has. Okay, now typically batteries are specified as ampere hour. Okay, so if it is 40 ampere hour battery, it can discharge more than 40 amperes. Okay, 40 ampere hour is the energy. Okay, but with that I can draw 80 ampere hour for half an hour. 40 amperes it can give for 1 hour, 80 amperes it can give for 30 minutes, 160 amperes it can give for 15 minutes. Like that, this is known as C rating. LiPo batteries have C rating of even 30. That means the complete energy it can discharge in 2 minutes time. That is called 30C. So C refers to discharge rate, how fast it can deliver the energy. So if your battery is only 2 ampere hour, it can give 20 amperes for 6 minutes. Okay, so so lithium polymer used to have higher ampere hour rating, C rating, but lithium ion has lower one, and so on. Now the next is the frame and landing gear. You are familiar with that, and you need to have controllers. Recently for my class, what we did, we developed the controller using Arduino. Otherwise, professional controllers are from DJI and Pixhawk, but we made out of Arduino. And recently we replaced Arduino by Node MCU chip. And then in the first semester we did control using the mobile phone. Students, we gave them the Android code, they downloaded their smartphone, then the joysticks appeared as icons there, then they were able to control. So that drone costed us hardly 7,000 rupees because we didn't have to buy the transmitter. You have several types of sensors in the, see, you have something like 8 and 12 rotors, but what you have in your joystick, there are only 4 controls. Okay, throttle, yaw, pitch and roll. So you have 4 controls, but on the drone you have 12 parameters or 12 RPMs to be controlled. How do you do that? So you need to have a control logic built into your system, and that uses various sensors. There are accelerometers, gyros. They combinedly study together and tell what is the movement in terms of velocity and acceleration along the various 6 directions. Then accordingly the controller takes decision. Then you have the pressure sensors which tell you what is the speed at which you are flying or what is the altitude at which you are flying, very roughly. If you want more precise altitude control, then you go for LiDAR or you go for ultrasonic controllers. If you want to have accurate position control, you have geographic positioning system, GPS sensors. Like that, there are several sensors available which you can pick and place and then use it. Okay, these are some of the interesting manned drones. This is from a Chinese company called Yihang, very reputed system. This is an American product. Of late, I'm not able to hear anything about it. An interesting feature of this is it doesn't run on battery. It has a generator set, a Honda diesel engine, drives an alternator, then they create DC power which is driving that. So this we call as hybrid. Unfortunately, there is nothing more heard about this. I'll skip the videos for want of time. Now, this also we have seen. There are different types of power plants possible. For example, you can just tie the drone to a ground. That is known as tethered. This is a tethered arrangement where the water and power required, these are all the solar panels in the building. If you want to clean it, you can have a cable through which power for flying and water can come, or power can be using the battery and water can come depending on the application. So it has several applications. You can have solar panel cleaning, you can use it for firefighting, you can use it for retransmitting the signal in hilly regions. So tethered flight is something which has a lot of utilities, but it is not interesting to the hobbies. Battery drone is the most common drone we are talking about. And hybrid drone is the one where you have a generator set which produces the required electricity. And this is something very interesting. I would like to show the video. He's a crazy guy. He bought 8 engines, connected propeller, and he has cranked all our 8 IC engines. He has cranked them. The video probably the view is not good. So all our IC engines driving the propeller, and the throttle is controlled by a servo. It's a single seater. He's flying already. Interesting, you will find that IC engines cost 1/3 in price, and they can fly for easily 90 minutes. So the net benefit is in terms of endurance and cost about 10. So taking idea from that, we also built our thing. We bought 4 engines from Germany, very light engines, and then we cranked by hand. So by hand we had to crank it. This is a petrol tank. We are still working on it. There are a lot of vibrational issues. We are trying to overcome that. So it can easily give 90 minutes. Right now the vibration is disturbing the sensors. We have put some mufflers. Let us see how it goes. And this our generator set. I told you, IC engine can drive an alternator. So this is also something we are working on it. Together it will weigh. This is 4 kg, this is 4 kg, then DC-DC converter and rectifiers, power electronics will be 2 kg, about 10 kg. Together we'll be able to make it. And this is something known as hydrogen fuel cell. It runs on hydrogen. What you see here is a hydrogen tank. This can fly easily for 5 hours or 6 hours non-stop. It's very, very expensive, but this is the emerging technology. One important benefit is long distance coverage. Second important benefit is it is green because the exhaust is H2O, steam. And this I already showed you in the beginning. These are known as tip jet helicopter. These are also very exciting to work on. And this is our drone ambulance. We have discussed about it earlier. This video also I showed you earlier. So this is our ambition. We'll land on the terrace like this, pick up the patient or the organ, go to the hospital terrace and land. That is the ambition. So I'll come to the conclusion slide. Our ambition is to develop a very safe, rapid and affordable drone ambulance. We need at least 2 crore money. We are running around for that. Now, it is nothing but a platform of 250 kg payload, and depending on the power source used, the endurance can be from 20 to 30 minutes up to even 6 hours. So, and we are using a stainless steel structure which is having good fatigue life. It is strong, it is very, very cheap. So we have several options possible in drones. So depending on the applications, you can decide what is the payload you need, what is the endurance you need. Depending on that, you can select what type of power plant, whether it should be quadcopter, whether it should be hexcopter, whether it should be coaxial type or in-plane type. So it's like cooking, you have recipes available to suit different applications today. So we are running around for money in order to build this drone ambulance. Let's see how much I succeed. Thank you very much. These are my contact details. You can shoot it probably. Thank you very much. I stop here. If there are question answers, we can take up.
Thank you, sir.
Was the presentation going well, audio visual wise?
Yes, sir. Yes, sir. Good, sir. Very good, sir.
Perfect.
Now the forum is open for questionnaire from the participants. The participants can raise your doubts and questions
Lot of hands is going up.
To our today's session speaker.
Thank you. A lot of claps are happening. Thank you very much.
Thank you, sir. Thank you, sir.
So it says open queue. Am I supposed to open the window?
Sir, one question from the chat box, sir. What is the type of motor used in your drone?
BLDC. BLDC, brushless DC motors. It's very common.
Thank you, sir.
Yeah. Very expensive, but very reliable. And you know, the brushes used to give trouble with the regular DC motor. So BLDC is very popular. And if you want to know the company, T Motor, you know, all are Chinese. The Chinese people are doing extremely well. T Motor, just T Motors in China. And recently I have located something called MAD. MAD motors are also very good. I mean, price to performance, you may find equivalent things in the European and American market, but they are at least 3 times more expensive.
Good evening, sir.
Yeah, good evening. Yeah.
Sir, and what about the software configurations we need to consider, sir?
Today, everything is readily available. You know, we use a controller called Pixhawk. It's again a Chinese controller. And there's an open forum where people share all the code. See, when I started in 2005, we had to buy individual triaxial accelerometers, gyro, we soldered them together. Then we had to write what is called Kalman filter. All that is gone today. Today, when you buy the DABA, the small chip, it contains everything. IMU, it's called IMU, inertial what? IMU is the energy and what? Magnetic or something. Okay, that contains accelerometer, triaxial accelerometer, triaxial gyro. It also has pressure sensor. So it tells you completely the attitude in terms of velocity and acceleration. So you don't have to, it's more like selecting the menu. You know, whether it's quadcopter or hexcopter or coaxial, it's like a menu selection. You have to just tick the boxes and then tell the center distance, the RPM range of your motor, diameter of the rotor. Then, you know, it takes care of everything.
And you have used the 80 AM amperes motor battery you have used in the sir? 80
Okay. What we are using currently is 30 ampere hour.
30, sir?
30, but the same company already has 40 ampere hour.
So is it sufficient for 5 motors or 3 motors, sir, for running at 16 minutes?
We use, see, one battery, one cell it gives about 3.7 nominal voltage. It varies from 2.5 to 4.2. So nominal voltage we normally take for design is 3.7. Yes, and our motors can take up to 60 volt of power because beyond that it will burn. Okay. So 60 volt translates into 14 cells in series. Okay. So our battery has 14 cells connected in series. So then you can assume that it is 60 volt battery giving 30 ampere hour. Okay? So one battery is 60 volt, 30 ampere hour. We use 12 of them. For each motor, we use one. Although they are connected in a single bus bar, we use one for each. That is how we are able to get about 15 minutes of flight.
So, and weight, sir, it means...
weight, one battery weighs 6 kg for us. So 6 into 12, how much? 6 into 12 is 72, right?
72, sir.
72 kilo goes per battery alone. The flying mass along with my weight is around 240 kilo. 240 kilo.
Okay, sir.
Yeah.
Thank you, sir. Very informative session, sir.
Yeah, we need a lot of youngsters like you to join and, you know, jump. In fact, recently, Kakinada or somewhere, a guy has flown very similar to us. He has given a lot of promotion. Where is it? I forgot the location. Many of you might have come across that. So a lot of things are happening in all over. And Andhra is very popular for agricultural drones.
Recently, Bangalore, one startup company have introduced flying taxi, something like that.
Okay, see, these things keep happening, but let me tell you, this will not become a reality.
Okay.
Ambulance will become a reality because, see, think of what will happen if it flies over a market and falls. Okay, so that is the safety part of it. There is another word, security. You know, in Bombay, one fellow had a machine gun. He went to Bombay VT and shot about 100 people. If such a fellow gets a drone like this, what kind of havoc he can create? So safety and security are two important concerns, because of which I don't see air taxi becoming popular. It will be used by VIPs, it will be used by army, it will be used by police for traffic control, but you and me cannot use it.
But for ambulance, it is very good.
Yeah. Ambulance is a very noble cause, so life saving. You know how many people die in the road by road ambulance? You are not able to move in cities like Bombay or Hyderabad. So it will be a very noble project.
Sir, one more question, sir.
Yeah.
How can the altitude difference of different geographic location like hills, mountain areas?
I'll give you the answer. At 15,000 feet, your engine power loses by 40%. So you have to directly multiply by 0.6. If the power is 150 kilowatt required for sea level, what you get at the top is 0.6 into 15, which is 90 kilowatt. Typically, you talk about Siachen or Arunachal Pradesh areas. So that's a kind of loss. So we have to overpower it. I want you to remember something very important in terms of energy efficiency. Planes are the best. Next is a helicopter. Drones are the worst in terms of energy efficiency, but then we can add more batteries, more power packs, and compensate, because the safety levels are very high and the center of gravity tolerance is also very high in drone. So it is worth running at a little bit lower energy efficiency, because safety is extremely high.
Thank you, sir.
Thank you.
Now it's my pleasure